Hello, everyone. Welcome to the Geo for Good Lightning Talks. This month is our fourth round of Lightning Talks, and the theme this month is crisis response. My name is Christian, and I'm a developer relations engineer here on the Google Earth Outreach and Crisis Response teams. Earlier this year, we started a series of monthly Lightning Talks by and for nonprofits, researchers, and other changemakers who want to leverage online mapping tools and technology for positive impact in the world. We hope these short lightning talks will give you a taste for some of the great work being done in the crisis and disaster space and inspire you to think of new ways that you can have impact with mapping tools or to open your eyes to new techniques to improve your own work. I am very excited to welcome 7 fantastic speakers this month. We have Avery Sanborn from the U.S. Department of Agriculture, who is mapping flood impacts on agriculture in the U.S. We have Anirudh Dutt from Let's Be the Change, who is using My Maps to help clean up the cities and map the COVID crisis in India. We have Rob Nappel from Cedar Digital Core, who is using Google Earth Studio to produce rich 3D visualizations of wildfires and other crises. We have Bessie Schwartz from Cloud to Street, who is doing advanced flood mapping to help countries around the world increase their resilience. We have Yifan Ban from the KTH Royal Institute of Technology in Stockholm, who is using big data and artificial intelligence to map wildfires. Mohammad Ardha from Indonesia's Remote Sensing Application Center, who is using Earth Engine to map flood impacts, and Sander de Haas from SamSamWater, who's building a map toolbox for locating and planning refugee camps. So before we kick off the presentations, I would like to call your attention to 2 things. First is the Q&A feature below the video here. If you're watching live, you can write your questions in the Q&A section down below the video. And if you have a specific question for any speaker, please identify which speaker it's for. The second is a link to the slides, which you can find below in the resource section. All right, let's begin. So our first talk is from Avery Sanborn, who is a geospatial analyst at the U.S. Department of Agriculture, the USDA, their National Agricultural Statistics Service. She helps produce and map the cropland data layer, the CDL, which provides freely available agricultural land cover data based on remotely sensed imagery. As the disaster monitoring team lead, Avery helps to produce timely maps, reports, and data related to natural disasters such as hurricanes, wildfires, and dercheros. Let's hear how she's using Earth Engine to map flood impacts on agriculture.
Hi, my name is Avery Sanborn, and I'm the disaster monitoring team lead at the U.S. Department of Agriculture, National Agricultural Statistics Service, or NASS as I'll refer to it. Agricultural disaster mapping and assessment are important for a variety of uses, including food security, emergency assistance, and ag statistics. The disaster mapping team at NASS is tasked with monitoring agricultural disasters in near real time and providing quantitative assessments of affected land using a variety of remotely sensed data and geospatial techniques. This supports NASS's mission to provide timely, accurate, and useful statistics in service to U.S. agriculture. The disaster mapping team assembled in 2017 as a response to the active hurricane season. And since then, NASS has responded to several disaster events. Prior to 2020, methodology included several time-consuming steps and various software requirements. But by using Google Earth Engine, or GEE, NASS saves time producing inundation data layers and is a more cost-effective alternative. One aspect of Google Earth Engine that is useful to NASS is that it hosts the data on its platform already. Sentinel-1 synthetic aperture radar imagery is used to detect water and changes in the landscape before and after a flooding event. NASS also produces the Cropland Data Layer, or the CDL, each year, which is also hosted on Google Earth Engine. So these screen captures show radar imagery and the 2019 CDL over the Delta region of the United States in response to Hurricane Laura from August 2020. NASS developed a user-friendly code to assess change in imagery. And so the user selects an area of interest in the map, specifies a date range for before and after the flooding event, and then selects the reference cropland data layer year. Once the code is run, the map shows areas of inundation over all land, shown in blue in the zooms, and more specifically, all croplands shown in green. Finally, the data can be exported through Google Drive for use in internal maps and reports. And this map shows the impact of inundation from Hurricane Laura on the US. So the data was also intersected with crop-specific information and showed that over 7% of planted soybeans and over 6% of planted cornfields in Louisiana were inundated as a result of Hurricane Laura. In summary, NASS monitors agricultural disasters in near real time, provides quantitative assessments for decision support. And this capacity is largely possible due to freely available and timely geospatial data and software such as Google Earth Engine. And these data products are delivered to NASS stakeholders internally, but they're also made available to the general public on the NASS Disaster Analysis website, which you can find linked in this slide. Thanks for your time.
Thank you, Avery. It's great to hear how you're leveraging the data and computation in Earth Engine to more quickly and easily produce flood maps. Do you have any examples where you're making this information available, either to other agencies or to the public, and where that's had a positive impact for response, recovery, or otherwise?
Sure. So the first time we used Google Earth Engine was for Hurricane Laura, which is what I showed in the slides. And in this case, we were able to evaluate 3 full states rather than a much smaller impact area due to Google's pre-processing power and computational abilities. And then we saved time where before the processing took hours, and then with Google Earth Engine, we're processing in minutes. So this means that we can get our final products and our data to our agricultural statistics board faster. And that's the agency that meets to determine the official monthly estimates for major commodities. And the Ag Statistics Board is also releasing weekly crop progress and condition reports in which they determine the percent of corn or soybeans in certain growing stages, or if their progress is very poor to fair to excellent. So we're glad to be able to support their estimation process in this way.
Fantastic. It's great to hear that you're leveraging the tools in that way. All right, let's go on to the next talk here. So our next speaker is Anirudh Dutt. He is an Indian social entrepreneur who founded the organization Let's Be the Change in 2013. They have a mission to clean up the city of Bengaluru. Let's Be the Change aims to build a cleaner, healthier, and more sustainable society by working in synergy with citizens and government. Today, they have over 15,000 volunteers working towards this mission, and his team is building a sustainable waste management system in urban poor settlements. Let's listen to how they are using Google My Maps to plan their work, as well as for mapping the COVID-19 crisis in India.
Namaskara. Hello, everyone. So today I'm going to talk about how we use Google My Maps. So in the index, I'm going to show you what initially our organization does and show you how we use Google My Maps there. And number 2, what we used, how we use Google My Maps for the COVID crisis. Number 3, I'm going to show you the impact which we have created till today. So we started out as a student-driven organization working towards the mission Clean Bangalore. So today we stand out 8 years where we have done 500 plus activities, and we have 15,000 plus volunteers with us, and we have 10 lakh plus beneficiaries. Our main vision and mission is to bring a clean India. So you might be wondering what we do. So we transform such ugly garbage dump places you see in the picture into this, completely beautifying it. So here's another spot. So we have done 250 plus such kind of transformations. So what we do is people can report such issues to us in the organization, and we put Google My Maps wherein we utilize this tool to put out all these informations. And once we have addressed these issues, then we put it up in this information. So you could see that how it was before and how it is after. So at the time of COVID crisis, I'd like to show you a tweet of one of our commissioner. So he's showing 31 fever clinics which was set up by the municipality. So you can see here, people had to go through these sheets to identify their nearest COVID care center or the testing fever clinic. So what we did was we took this information and then we put it up in a Google My Maps platform, and then the commissioner again tweeted it. So people could just click on the link. So once they click on the link, they could easily get all this information in their Google Maps application itself. So they don't really have to go through a lot of sheets. Similarly, we did this initiative with different commissioner as well. This is Rohini. We did it with her to geotag some of the essential stores. Similarly, we got a little ambitious and we thought we could help more people across our state, which is Karnataka. And then we geotagged all the COVID care centers and the hospitals. Similarly, we then scaled up to across India, and then we geotagged all the COVID care centers and all the hospitals where people could identify it very easily. So till today, we have impacted, we have created close to 25 maps, which has more than 18,000 plus information is available, in which we have benefited more than 10 lakh plus people who are still utilizing this particular information. So thank you. This is a small talk about what we are doing and how we are using Google My Maps application. So if you have any kind of queries related to Google My Maps, please do reach out to me. Thank you.
Wonderful. Thank you so much, Anirudh. Great work with My Maps for both your sanitation work and the COVID work. I'm curious if you're using the collaborative editing features of My Maps, and if so, how many people do you have editing the map at the same time?
So we had, I think, close to 15 to 20 odd volunteers who were editing at the same time and adding the respective states' information there. So we were also using volunteers that, there's a wonderful feature where they could easily add their respective inputs and make it uniform. So that way we had close to 15 to 20 people using it at the same time.
Fantastic. And have you found any features or best practices for creating and sharing My Maps that you might want to be able to share?
Yes. So one of the best feature was adding the Excel file, the Google Sheets from the Google Sheets directly into the map. So we were able to just put in the lats and latitude and longitude, and then the complete data would get into the map. So that way volunteers wouldn't have to spend a lot of time entering each of the information. So that's one of the very nice features where we could directly add the KML file into the My Maps application.
Fantastic. Great work. And thank you again.
Thank you.
All right, let's go on to our next talk. The next talk is by Rob Nippel, who is Vice President and Technology Innovation Lead for CEDR Digital Core, which uses technology, social media, and digital volunteers to crowdsource and communicate critical information during natural disasters. Rob is responsible for envisioning and implementing new technologies and approaches to improve CEDR's or CEDR's disaster response efforts. Let's see how he's using Google Earth and Earth Studio to visualize wildfires and other crises.
When natural disasters strike, public awareness and understanding is crucial, but traditional communications methods like 2D maps and text can be inadequate to convey the complex geography and scale of an incident like a major wildfire. By creating 3D animations with Google Earth Studio, CEDR provides the public with a perspective that's both visually compelling and easy to understand. Compare the official lava fire on the left below with the corresponding CEDR animation on the right, and I think the advantage of the Google Earth approach becomes clear. CEDR's primary use case for Google Earth has been wildfires. For major fires, aircraft perform infrared mapping flights overnight, and the next morning that data is published in KMZ format. By bringing that data into Google Earth, we're able to create flyover-style animations, giving the public a real sense of the geographic context for each fire. Shown here is a snapshot from 2 major fires that impacted Arizona in early June. In addition to the infrared data, CEDR adds place marks and other notes to ground the viewer's perspective with familiar landmarks and provide them as much useful information as possible. Here we've provided the current size of the fire in acres, as well as the population of nearby towns. We also used Microsoft's building footprint dataset to highlight individual homes and structures, indicated here by the bright blue lights. CEDR is continually experimenting with new variations, exploring Google Earth's full and evolving potential. Top left is a GIF animation showing the progression of the Beckworth Complex fire over a 4-day period earlier this month. Below that is a clip from a video which visualized damage assessments provided by the city of Santa Rosa following the glass fire as polygons over Google Earth's 3D buildings. And on the right is a category I hope to avoid in the future, showing the fire siege California suffered last August, in which we start with a view from orbit and zoom down to a detailed flyover tour of the major fires burning at that time. Another variation incorporates photo views from the Alert Wildfire camera network, which has over 800 publicly viewable cameras. They provide an amazing resource to view fires in near real time, but it can be challenging to understand exactly where each cam is and where it's pointing. By starting with a familiar view from one of the cams and fading into the corresponding view in Google Earth, we provide that missing context. CEDAR's Google Earth animations have received near universally positive feedback. We see them being increasingly cited by media organizations, as well as being incorporated in official agencies' public releases. Our primary focus is informing the public, but we're delighted to see that our work is also proving useful to emergency management professionals. Our Google Earth work is just one part of CEDAR's approach to wildfires and other disasters, which includes mapping wildfires on the Fire Mappers map, CEDAR's own shelter map, and our continual work on social media to amplify and clarify evacuation orders and other crucial public safety announcements. Wildfires are where we've utilized Google Earth most heavily so far, but we continue to explore how it can be valuable for other types of natural disasters. Shown here is a sample from a proof of concept video showing a Civil Air Patrol photo of flooding from Hurricane Delta overlaid on its corresponding Google Earth view. Thank you, and I look forward to your questions and from hearing from you if you'd like to know more or to learn about potentially joining CEDAR as a volunteer yourself.
Fantastic. Thank you so much, Rob. It's really good to see these advanced uses of Google Earth and Earth Studio. So I'm curious, what have been your biggest challenges? And on the flip side, what's next? What are you looking forward to do?
So I think one of the biggest challenges that's surprised me a bit is because Google Earth Studio provides basically a full video editing suite, we've kind of had to learn how to make movies. So the entire art and science of knowing where to put a camera, how to move that through space in ways that don't disorient the viewer, et cetera, has been an interesting thing to learn and something that we're trying to lean on the strength of our volunteer corps to bring in folks that have that skill set as opposed to the technology skills that I or others have. In terms of where we're going, new data sources and new hazards are really where we're exploring. So looking at not just wildfires, but hurricanes, other hazards, and there's just a host of amazing data sources out there, and looking at things like the flood mapping and cropland vegetation that the earlier speakers have mentioned, strike me as things that might be interesting to try and bring in as well.
Fantastic. Well, thank you again. And we'll go on to the next talk now. All right, next up, we have Bessie Schwartz, who is the CEO and co-founder of Cloud to Street, which recently raised a large seed from some top investors. It's the leading platform for monitoring, mapping, and analyzing floods and flood risk around the world for the most climate vulnerable communities and governments. Bessie is an expert in designing and implementing products for the low and middle income countries and communities, as well as in human-centered design for empirically based disaster response tools. Cloud to Street has been doing amazing work leveraging Earth Engine to expand the state-of-the-art in flood and vulnerability mapping. Let's hear what they've been doing lately.
It's probably no surprise to everyone here that the world is unprepared for climate disaster, and floods are the tip of the spear. Floods affect more people and more property than any other disaster. And yet the flood information we have today is insufficient for the challenge, for practical disaster risk reduction, and to build the financial protection we need. While great science, traditional flood maps depend on modeling and local ground equipment. And as you can see on the map on the left, when you put 6 of the leading models on top of each other over the continent of Africa, they largely disagree on where the floodplain is. If you zoom into what this looks like on the ground, you'll see that disagreement in the yellow and red, and none of the models effectively capture the devastating 1988 flood outside Khartoum in Sudan. So Cloud to Street knew we could do things differently by leveraging satellites to look directly at floods from the sky. One thing we're doing is releasing the largest database of flood maps in the world. One thing this has done is revealed 58 million more people living in the floodplain. That research is actually going to come out in Nature, pretty shortly. It's already been accepted. And we're also releasing all of the flood maps for free behind this data set. But, that's just one satellite. What's actually required for practical decision-making on the ground is leveraging all satellites around the world and creating flood information systems that work for governments, insurers, and others. Let me give you an example. Take you to the Republic of the Congo, where in 2017, 5,000 people suffered from a major event, but the government took 3 weeks to understand the extent of that problem. So during the next rainy season, Cloud2Street set up an all satellite-based flood information system that scanned every inch of the country every day to look for disaster. I'm proud to say they're still relying on this system years later. Many examples of how this has changed decision-making. I want to give you one of them. In 2018 or 2019, a large number of refugees from the DRC moved into the ROC. The question is, are they at flood risk? So they used our system to look back in time, to look at the pattern of flooding in those refugee camps and find that 7,000 of the asylum seekers were at flood risk. And they used us to relocate them. That's a good thing because a couple months later, that refugee camp area was completely inundated by a major disaster. Today, Cloud2Street is monitoring 80 million people around the world and has helped local users like the WFP and the local government help bring aid to over 500,000 people with this system. We're taking this work now with global insurers to bring disaster capital to people who are currently uninsured. Please join us to create the future of flood resilience.
Thank you, Bessie. Amazing work as always. It's great to see you continuing to leverage Earth Engine in powerful ways, both for research and for impact on the ground. So what do you hope to see come out of your release of the new flood maps that you've created? And how do you foresee people using them, or what impacts do you hope you can have in the next few years?
Yeah, thanks so much, Christian. And it's such a pleasure to be here with such an impressive other group of folks. So really the first thing and the real desire between publishing in the, forthcoming Nature paper, not yet out, is really first to help others in our research community better understand the problem. That's one reason we want to just release all the data for free. So we as a research community can complement the old forms of really understanding flood modeling as it continues with the new form that many here are also working on to really understand better the true scope of climate change as it's changing. The second real purpose was to open up all of these data to communities and folks at the local level to start advocating for protection or other types of financial products that they really need. So just as an example, you could overlay a historic flood map on top of the official flood map or other models for your area to just look at discrepancy between what's predicted and what has actually happened in events in your area.
Fantastic. Yeah, I look forward to seeing all those maps when they come out soon. So what else is next for Cloud2Street? Yeah,
so I mean, really excitingly, I mentioned that we are helping to monitor 80 million vulnerable people. Numbers actually just been updated to 122 million people because we've added in some countries since I gave this talk. But the thing is that while data is critical to understand the problem and it's critical for then taking action, we hear time and time again from communities and governments and companies that data actually doesn't mean that much unless you have the resources to take new action, whether it's search and rescue, whether it's new infrastructure or relocating communities. So what we're really excited about working on now is partnering with our global insurers and reinsurers and brokers who we've been working with in order to build new forms of dynamic insurance, like parametric insurance, that are able to release payouts more quickly to more people for really the 70% of the world that just doesn't have that kind of protection today.
Fantastic. Well, great work as always, and thank you for the talk.
Of course.
All right. Our next speaker is Yifeng Ban, who is a professor and director of the Geoinformatics Division at the KTH Royal Institute of Technology in Stockholm, Sweden. Her research focuses on multi-temporal, multi-sensor remote sensing, AI-powered Earth observation big data analytics for mapping and monitoring global environmental changes, including near real-time monitoring of wildfires, continuous monitoring of urbanization, and analysis of environmental impact to support sustainable and resilient planning. Let's hear how she is using Earth Engine's Earth observation data and artificial intelligence tools to map wildfires.
Hi, everyone. I would like to present my research EOAI for wildfire, Earth observation, big data, and deep learning for near real-time wildfire monitoring. As you know, in recent years, wildfires have increased in intensity and frequency, and wildfires have significant economic and environmental impacts. Since the launch of Landsat in 1972, many Earth observation satellites have been launched. They can provide near real-time monitoring of wildfires. In this research, we investigate Earth observation big data in general, Sentinel-1 and Sentinel-2 time series in particular, for near real-time wildfire progression monitoring with deep learning. We have developed 2 deep learning frameworks for wildfire progression monitoring. On the left is on-the-fly learning and training. Basically, whenever there's a wildfire happens, we take the image and we train using the burned samples on this image and make the prediction. And on the right-hand side is transfer learning. We use all the past wildfires to train the network to recognize wildfires. So when there's a new wildfire, then we use the trained network to predict fire. So this will be faster because there's no on-the-fly training. If you're interested, you can look at the 2 papers we published recently. So the results are very promising. We demonstrated that Sentinel-1 and Sentinel-2 data can be used for near real-time monitoring. We have developed a Google Earth Engine app for wildfire monitoring in British Columbia and in Sweden. I'm going to show you briefly our wildfire app. So here in Google Earth Engine, you see all the red dots are wildfire hotspots, the active fires today. And for any area, you can use a rectangle as, draw area of your interest, and then we will search for all available satellite images in Google Earth Engine for wildfire monitoring. So here is the result. So we have searched the data, so you can see a list of all images available. And the latest one is from yesterday, so there's a 1-day delay. So here you see it's a Sentinel-2 image with higher resolution, and you can see smoke and active fires and burned areas. And so the layer on top is active fires, so where the fires are active. And then the next is the progression, how the wildfire progresses over time. Then the next layer is the burned area mapped with high resolution Sentinel-2 images. And then you can also look at the Sentinel-1 burned area mapping mapped with our method and compare to VIIR's coarse resolution data. Sentinel-1, Sentinel-2 provide more detailed information on burned areas.
All right, fantastic. Thank you so much. It's great work combining machine learning and Earth observation data. So do you have any examples of how your maps have been used to help fight fires or recover from wildfires?
Thank you, Christian. Yes, we have been working with 2 users. One is British Columbia Wildfire Services. The other is the Swedish civil contingency agencies. So in BC, for example, right now there are over hundreds of wildfires are ongoing and threatening communities. They declared state of emergencies yesterday due to the fires. So we have shared our app with them several weeks ago. They were involved in developing the apps. So this is definitely one of the data sources they can use. They were very excited when they saw the app about the prospect of being able to compile a variety of satellite data from coarse resolution to more detailed maps at 10, 20 meter resolution, compile them together to produce near real-time progression mapping in a reliable manner. So I do hope this, is useful, helping them to fight the ongoing wildfires. Another aspect that they really like is that they haven't really used radar images for wildfire monitoring. So we have actually been in contact with the European Space Agency. They have made a special tasking in British Columbia for us. So now we have the images every 1 to 2 days. Actually, every day I checked, but sometimes it's one day skip. So you have daily images at night, because radar can penetrate through clouds, smoke, and also image at night. So you have an additional data source that our algorithm can detect fire using radar as well as optical. So yeah, I do hope that we can actually support, firefighting for all the affected communities.
Fantastic. So yeah, what else is next for your work? Are there other opportunities you see to continue and expand this research?
Yes, that's a very good question. We started with research and we work with, monitoring a few fires as a research project. Now we actually scaled it up to be able to monitor the whole Sweden, the whole British Columbia. So the next step will be to make it global. So we would like to be able to, train with different samples from different climate zones and make sure it works not only in the boreal environment, also works with Mediterranean climate, California, Australia, everywhere, globally. So more people, more users using this app.
Fantastic. That's great to hear. Well, thank you again.
Thank you.
All right. Before I go on to the next talk, I wanted to remind the audience that you are invited to ask questions of any of our speakers, and we will ask them live here after the next two talks. There's a Q&A section down below the video, so please go ahead and enter your questions there so that we can ask the speakers after the next two talks. All right, our next speaker is Mohammad Ardha. He is a researcher at the Remote Sensing Applications Center, which is part of Indonesia's National Institute of Aeronautics and Space. Mohammad is the task force coordinator for quick response in providing information about disasters. They leverage remote sensing data to produce information for other government agencies, such as buildings affected by floods, areas affected by landslides, and more. Let's hear about how he's using Earth Engine to map flooding in Indonesia.
Today, I will present the entitled Google Earth Engine role to support information related to disaster based on remote sensing in Indonesia. Okay, next. This is one of my remote sensing application center tasks, is to provide information about disaster based on remote sensing data, which it has to provide to give to society and other institutions in Indonesia. Okay, next. So we have to underline the objective to provide information disaster based on remote sensing quickly. Okay, next. This is my case study about remote sensing to monitoring flood in Konawe, which is already happened in a few years ago. I has a task to mapping a flood inundation in settlement or cropland area based on remote sensing data. Okay, next. For the data, I am using Sentinel-1. Sentinel-1 data is remote sensing radar data which has a C-band. It has an advantage, which is penetrate to cloud cover. You know, Indonesia is tropical country, has many cloud cover in every year. Okay, next. So for the methods, it is just simple. In my method, I'm just doing some correction from radiometric calibration and geometric calibration to find threshold to see what is flood and what is non-flood. Only the simple like that. Okay, next. Okay, maybe I can share you my apps. Here are my apps. You can see there is a part of the layer, this affected urban, cropland, flood area, and after flood. Here I got from UN Spider. You can see the blue one is the potentially flood area, which is a Haas inundation area. And you can see we have a result about the flood status, death, estimate number of exposed people, cropland, and any more. You can see in here. You can turn off the layer and something like that. Okay, next. Can we back to my slide? So the result of application is you can see the flood depth, flood extent, cropland, urban area, and estimate number of exposed people. Okay, next. So the application, we can further development. For example, for Indonesian area, we can overlay with the high resolution image. For example, Pleiades to see to count many building affected by flood. So it makes sure to validate between the field and the Google Earth Engine data, we can see it is right or no. Thanks for the opportunity.
All right. Thank you, Mohammed. Very nice work leveraging Sentinel-1's radar data to see the floods through the clouds. Very good. So I'm curious, how quickly after a flood are you able to produce these maps and show things like impacted buildings?
Actually, it depends of the availability of the data. You know, when we count the building in Indonesian area, we need the high resolution image, which is have a good in a time, not a gap time. For example, if it's happened now, it's better to get the affected area for tomorrow. But we have to see the quality of the data. For example, when you play this or spot or something, we have to make sure there is no cloud area in there. So we have another problem to see the availability data. But for the data, actually, we are doing some recording by using another institution like Remote Sensing Technology Center, also in part of Lapan. Also, just in case if we need something big, for example, another flood in Jakarta, we can doing a international charter disaster because we are the part remote sensing application center is part of charter, so we can activate it and get help from another country to support us the data. Thank you.
All right, sounds good. Very good. Yeah, and do you have any examples of how your work has been used in the field?
Actually, I don't have an example because we just provide information to other institution. For example, we give information to National Disaster Management Agency. It's called PNPB in Indonesia. But so far, I think there is no complaint for them. Even they are also say thanks to me, say thanks to Lapan to provide information, and they say they can give provide an overview regarding disaster management. So I think it is good because there's no complaint from them. Okay.
Sounds good. All right. Okay. Thank you again.
Thank you.
All right. Our next speaker is Sander de Haas. He is the co-founder of SamSamWater and also a landscape restoration expert at Just Dig It. Sander is trained as a hydrogeologist and civil engineer and has a wide experience in water and landscape restoration programs throughout Africa. He combines practical insights from the field with innovative use of technology to support humanitarian aid workers during crisis response efforts and refugee camp planning. Let's hear how SamSamWater is using Earth Engine to better locate and plan refugee camps.
Hi, everyone. We support Red Cross and UN refugee organizations with technical advice on practical issues they are facing in refugee camps and in crisis situations. And often it's about supporting field staff with tools and visualizations to help them gain insights and solve problems related to water, sanitation, and spatial planning. So we work with field engineers, and they know how to read, use, and interpret maps, but often don't have the skills, time, and internet connection to make these maps themselves. And that's how we support them. And I noticed that on several occasions, I've been working on similar issues, similar challenges, and developing similar types of maps for different regions. One example is about site selection for refugee camps. This is very challenging. It's time stressed. There are many, many stakeholders, and there's often little data available to base decisions. And what you find in that, several refugee camps struggle with floods during the rainy season, since they've been constructed at sites that appear suitable during the dry season. When it starts to rain, they tend to get flooded. So what we do is we use freely available data sets and to help humanitarian aid workers and engineers to identify and visualize these possible flood zones. It's not only for technical purposes, since quite often those field engineers, they know where the flood zones are, but it's also to convince and show decision makers that certain proposed sites are really not suitable for what they intend to do. Luckily, there are guidelines and criteria for spatial planning of refugee camps. See, for example, this section from the UNHCR Emergency Handbook. And all the guidelines that I marked yellow here are based on parameters which can actually quite easily be derived from globally available data sets. It's only that these analyses have to be made over and over again for each new crisis situation or refugee camp. And that's why we are now working on a map toolbox. It's based on Earth Engine that does exactly this, to have a set of useful map layers ready for crisis response workers for the whole planet. So whenever and wherever there's an emergency, everyone can access this map toolbox, zoom into their area of interest and see the maps for that specific area. So I'll show a few examples from this map toolbox. This is just a general base map with contours, flood areas, flood risk areas in blue, and river patterns derived from a digital elevation model. The next one is a slope suitability for refugee camps based on the criteria that I showed earlier. The third one for the same area, a suitability for pit latrines based on the soil type and the proximity of borehole. And lastly, a recent satellite image just for a reference. So I want to emphasize this map toolbox is not to replace detailed specific mapping or field surveys, but it's to provide a set of readily available data layers that can be used as a starting point for humanitarian aid workers. So we now have a prototype of this map toolbox ready, but we seek partners and funding to further develop this and trial it on a few actual crisis response efforts. So if you're interested to partner up with me on this, please reach out to me. Thanks.
Thank you, Sander. Great work, and I'm looking forward to seeing which organizations are able to leverage this this tool set. Looks really good.
Yeah, thanks.
So how is this connected to the water supply work that you do at SamSamWater?
Yeah, well, actually, the idea evolved from our water supply work. And that example that I showed, for almost all projects, it's important to identify potential springs or shallow groundwater sources. And for that, I download digital elevation models, process them, and analyze the drainage pattern. But there are quite some steps in that process. And quite often you find out, most often towards the end, that you missed a section and you have to download another tile of the digital elevation model and do all the processing steps again. So after developing that map layer in Earth Engine, I quickly realized that this could be really helpful for others too. So it's not only for people in the water sector, but for infrastructure, spatial planning, and many other sectors as well. So it kind of evolved out of the water supply work, but it can be used much wider, I think.
All right, fantastic. And I'm curious, are there other data layers that you're working on or which you wish you could develop if the data was available?
Yeah, well, there's a long wish list. I think the flood maps, as shown by Bessie from Cloud to Street earlier in this talk, really cool. I'd love to add them and probably have a chat to each other and see how we can collaborate. Same for the flood maps that Mohammad showed. I think the map toolbox can be used for other sectors and other use cases as well. For example, I talked to people in the energy sector, and they're interested to find out which slopes are suitable for solar farms. So based on the direction towards the sun and the gradient of the slope. Same for hydropower potential of rivers, transportation, road networks, but even more advanced analysis to a road network. I think by combining some clever combination of data sets, you can probably derive and predict the quality of roads during the rainy season, which is often a very limiting factor for a lot of work being done on the ground. I think things like malaria prevalence or risk. So my experience is that once you start talking to the field staff, so people actually working with the boots on the ground, they come up with challenges that you can never think of from behind the desk. And if you start analyzing those challenges, quite often they can be solved relatively simply by maps and remote sensing data. It's only by talking and by actually doing it, you find out what it is and how to help those people. And that's what I intend to do.
Fantastic. Well, keep up the great work doing that.
Thanks.
Thank you again. All right. I think it's time to bring all the speakers back onto the screen. Let's see. There we go. I think that's everybody. Yeah, so thank you all for the great work and the fascinating talks, everyone. It is so inspiring to see all the ways that maps are helping you to have a positive impact on people's lives and livelihoods in times of crisis. Let's take a look at some questions from the audience. All right, thank you to the folks who have put these together here. So a question for Bessie that says, I am working on flood and how it is affecting marginalized communities for or slums in cities. Can you suggest something useful for my study?
Absolutely. I mean, I think many of the tools that the folks who talked about flooding here could be useful. And just to note that the database that we're going to be releasing, which is close to 1,000 flood maps, is also going to be a layer in Google Earth Engine. So you're going to be able to access it right from there. And that may be able to be useful for slums. One thing to note on that database is because it's 250 meter, it may not pick up the denser urban flooding. So I might suggest just two things that some other folks might be accustomed to here. One, you can use some of the higher resolution public or commercial data sets to track the floods and complement in there. And also look at just the pattern of flooding in the past at where those slums have been. Some slums are newer, so have come in the last several years. And if there was a pattern of flooding in that location before, it will likely predict what kind of vulnerability that area has now. The last thing that I'll just say is really to answer your question sufficiently, I think it would really require understanding a bit more about the use case that you're in. And really, I think with any solutions like many that we're talking here, someone pointed this out, I think asking the user first or the community who's the end beneficiary, really what they need. Because at the end of the day, there's a lot of cool maps. The advancements in AI and deep learning have really pushed the industry forward, and Google Earth Engine was really at the beginning of that. But really, at the end of the day, our users just want an answer. They don't even care about the pixel, they don't even care about the map, they don't even care about the analytic. They just want the answer to the question that they have, whether they're a sophisticated user in government or someone in a slum like many of the places that you're working with. So I'd say, obviously, I'm sure you're talking to them, but it really would depend on what they need on the ground.
Thank you, Bessie. Great answer there. And I hope that helps with the slum mapping. Let's see, we have a question from Rob here for one of the other speakers. I'm going to pass on that for now. Let's do the audience questions first. So let's see. This is a question from a PhD student at MIT who's also working on coastal resilience and flooding in Indonesia. This question is for Mohammad, and he's specifically working in Pekalongan, I believe. I'm probably not pronouncing that correctly. He says, thanks for your presentation on this interesting topic. I've considered using this UN Spider change detection-based flooding classification method, and I'm wondering whether you maintained the predefined threshold used to classify potentially flooded areas used in the change detection technique, or did you do any additional work to determine a custom threshold to classify the flooded areas? Let's take that part of it first. Mohammad.
Yeah, to be honest, for the threshold based on our experience in every area, it's different. For example, in urban area, in rural area, we still need some threshold which is good for the detection the flood. For example, the Sentinel-1 has many doing some correction like the backscattering data or for shortening data in the hill area or mountain area. It is make the threshold is change in another area. For example, in Java, we don't use that threshold. So but in Sulawesi, the threshold it's good. So I think it will be better if maybe my team and I or something can help to doing some machine learning to see the to see the threshold, which is good for Indonesia, especially.
All right.
And
Sounds good. There's another part to the question. It said, also, I'm wondering if you did any additional validation for the estimated number of people exposed and estimated affected urban areas outputs.
okay, because my task is like I said before, this is the quick response. So we don't do like the estimate people affected because it records another data, for example, statistical data or something for another institution, and it still need time. So we don't do that. Maybe if we have the best data is the hard to find, hard to complete. So this is the challenge for us. Hope we can be good in the data, so we can provide information, for example, to see the urban area which is affected or many people in house, for example, estimate one house have of 4 people, something like that, maybe. Thank you.
Great. Thank you, Mohammad, for answering that. Very good. Let's see. We have a question for Yifang from the audience. You said that your wildfire progression monitoring is currently available in BC and Sweden. How difficult would it be to get this information globally? Would additional satellites be needed, or is it just a matter of getting access to existing data? Well, in answer to my question earlier, you said you were working on globally. So hopefully, well, I'll let you take the question here, Yifang.
Yeah, thank you. Very good question. I think one is really now we have special sort of tasking of the high resolution data. So usually outside Europe, ESA doesn't acquire all the data because the limitation of satellite downlinking and all that. So to have this kind of data, so that means they will have to make this data on a daily basis available. Then I think for us, another thing is to really do better transfer learning. So we're improving our training of the deep learning models with more samples from a variety of fires around the world. So we're working on it. We hope to be able to deploy it very soon. Yeah, so the issue is the data and then improving the model.
All right, sounds good. Thank you. Let's see. Next question is also for you, Yifang. This is from Rob on our panel here, and he asks, what is the turnaround time for the analysis from time of observation by the satellites to final products within the Earth Engine app? And is there any plan or intent to utilize satellites other than Sentinel-1 and 2, such as maybe GOES?
Thank you. Excellent questions. Yes, so for us, from satellite acquiring data, the Space Agency in near real time release, that's called near real time, it's 3 hours. What we get is maybe between 6 to 8 hours. That's still pretty fast. And for us, as soon as we search their hub directly and we upload to Google Earth Engine right away because Google is having a 1-day delay. We would like Google to do faster. But anyway, so we process it on the fly. So you will get the result when you launch the app. It will do some calculation. It might does it for like a few minutes. So you get the burned area map right away. And the next question is about integrating with a different type of data, including GOES. And GOES images every 5 minutes, but very, very, very low spatial resolution. We actually did that as well because we don't do it for mapping because they're low resolution and not very reliable. So we do it for early fire detection. Sometimes we manage to detect fires maybe 2 hours, 1 to 2 hours earlier than the VIRS hotspot. So that's what we're using GOES for. But we try to use all type of data from GOES to MALDIS, VIRS, and Sentinel-2, and even Planet. So it's a variety of resolution.
All makes sense. That's great stuff. Great work you're doing.
Thank you.
All right, fantastic. I have 2 more questions here. We'll take them quickly. One is for Bessie from Sonder, and he asks, is Cloud to Street considering looking at other threats next to floods, such as wildfires, landslides, earthquakes, things like that? Bessie, any plans for other hazard types?
Yeah, certainly those climate disasters, including droughts, are on the pipeline. And we've done a little bit of that work as it's necessary for the communities that we work with, primarily landslides, because they often come part and parcel with the flood in many locations. And many of the places we work, will say to us, floods happen some time of the year, and then it'll be drought the other time of the year. And so multi-hazard is really the way that a community looks at it. With that said, our team is really a team of hydrology and AI experts that are focused on flooding. So that's really where our scientific expertise lies. So as we move more into these other areas, we will be bringing on a much more significant team who has expertise in the more kind of traditional disaster science for understanding those physical phenomena, and have some more computer vision experience focused in those areas. So definitely in the site, and will probably the next 2 years, I would say.
Great, exciting, thanks.
Yeah.
Very good. And last question I have here is from Rob, a question for Mohammad. He's curious whether base data is a challenge in your work, and says you're combining the Sentinel data on flooding with building footprint data to analyze the impacts. And as Rob discussed in his talk, he has been using the Microsoft building footprint data released for the US, wondering if there's something similar in Indonesia that you're using.
Yeah. Thanks for the question. You're right. I'm using combine using Sentinel-1 and food settlement area using from Google Global Human Settlement Layer. But maybe that's not good in accuracy. But for the data in Indonesia, of course we have it, but not it. We don't have in my institution, but in another institution, I think we have it. For example, we have already doing some mapping in land use land cover and mapping for census of census of population to make sure what is where how many home in this area, for example, like that. But we have like I mentioned before, for me the task I doing is to provide quick information, quick response. So for another research to provide combined with the high accuracy data, maybe we are talking next research or something.
Sure. Yeah, thank you. That's good. That's great stuff you're doing. Thank you.
Okay.
All right. Well, I want to thank all of our speakers so much for the fascinating talks, the incredible work you're all doing, and for joining us, especially some of you who are in parts of the world where it's very late at night right now. So thank you again. And we look forward to seeing where you take this in the future. And I hope to see you again at another Geo for Good event. So thank you, everyone.
Thank you.
I also want to thank the audience for joining today's session. We appreciate all your questions. We hope that this session was helpful and inspirational for your current or future projects. And we hope that you will join us again for next month's lightning round, which will be about nature conservation. So we hope to see you then. Thank you, everyone.
Thank you.